Hello, how's it going? Today is 3-7 notes. Now 3-7 in Algebra 1 is absolute value equations. And your task is to solve them. We know the absolute value of -2 equals 2. That's because -2 is 2 units from 0. Two is also 2 units from 0. Whoops. So, the absolute value of -2 equals 2. Now these are the absolute value bars. And the absolute value of 2 is also 2. The absolute value of 2 is also 2 because 2 is 2 units from 0 also. Now solve the absolute value of x equals 2. This is really 2 equations because 2 numbers, 2 and -2, both are 2 units from 0. Right? So, x equals, or x equals -2. Could be 2, could be -2. Now notice the bars drop. When you're done solving. Okay? So, 1, isolate bars. Okay, you may need to take a step to do that. This may need 1 or 2 steps. The second thing you have to do is set up 2 equations. Okay, and then drop bars to follow the definition. And then see, just like I did here. Here's the equation, the absolute value of x equals 2. You write 2 equations and the bars drop. Okay, and then 3, solve both. And then I like to call this 3a, is watch out for the negatives. Watch out for absolute value of x equals -2, because this is no solution. Okay, so sometimes when you isolate the bars, there's a negative. Isolate those bars, there's a negative equals a negative. That's no solution. Okay, so watch out for that. All right, let's do a couple examples. And I'm going to leave this up here. So we'll do the couple examples right here. Example 1. The absolute value of x minus 8 equals 7. So the bars are isolated. So I really don't have to do step 1. Now, step 2, set up two equations and drop the bars. So the one equation is x minus 8 equals 7. Or, now you can't have the same equation, and since the absolute value of a number is both the positive and the negative, so the absolute value of negative 2 is 2, and the absolute value of 2 is 2, what's the other equation? Well, it's the negative of what it equals. So x minus 8 equals 7, or x minus 8 equals negative 7. Because the absolute value of 7 and negative 7 is equal. All right, so I'm going to solve both of these. These are pretty easy. X equals 15. Or, add to 8, x equals 1. All right, now substitute that back in. 15 minus 8 is 7. 1 minus 8 is negative 7, but the absolute value of negative 7 is 7. So we get two solutions there. All right? Now you can back this video up and copy that problem down, but I'm going to want this room right here, okay? So I'm going to do another example. Maybe I'll just write it down here, write kind of small. Example 2. See this okay? All right. So one that you might have something that looks like this, all right? The absolute value of negative 3n, I did that twice already, just leave it there, plus 5, okay, equals 20. Now, so when you isolate the bars, these bars are not isolated because this term, plus 5, is with it. So like I said, you may need one or two steps to isolate the bars. So the one step I'm going to make in this example is subtract the 5 from both sides to isolate bars. Now, I end up with the absolute value of negative 3n equals 15. Now, I'm going to bring this problem up here, right here. Okay, right there, and finish it right there. Okay, so this is negative 3, absolute value of negative 3n equals 15. Now I'm going to drop the bars, since they're isolated, and set up two equations. Negative 3n equals 15, and negative 3n equals negative 15. Okay? So, we're almost done. We're going to solve both of these, and I will use red, I guess. Divide both sides by negative 3. So here, n equals negative 5 or 5. So it could be negative 5 or 5. Now that one was a little bit trickier, okay, because we did have to move the 5 over first, because you have to isolate the bars. Okay, you have to isolate those bars. All right, one more example for this video, and we are done with these notes. Okay, at least part 1. All right, so think about that, how you do that. You're going to get two solutions. All right, so this is example 3. All right, here we go. This space right here, example 3. Okay, example 3, and that is going to be looking like this: negative 6, the absolute value of 2x plus 5, right, equals 24. Okay, So I'm going to isolate the bars. Now you may need one or two steps. In this problem, I'm going to divide both sides by -6. Divide by -6. And I'll divide by -6. And those -6's cancel. So now I have the bars, the absolute value bars, 2x plus 5, the absolute value of 2x plus 5 equals -4. Now, the alarm should sound. The alarm, beep, 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 beep. The absolute value of a number can never be negative. It will always be positive. So stop, recognize, no solution. Okay? So why is it no solution? Because the absolute value equals a negative. Equals a negative. When that happens, you must remember that there is no solution. Okay? So those are your examples for 3-7. The assignment is on the Schoology page, and the answers are on the Schoology page. So practice makes perfect. Well, not perfect, but as best you can.